Okay, so when we left off last time, I had asked you to complete these questions on your own. We had looked at a video on the 3 things that affect the rate of dissolving. For a solid and a liquid, they were stirring, temperature, and particle size. The 2 parts of the solution are the part that is doing the dissolving and the substance that gets dissolved. And the substance that gets dissolved is the solute, and the substance that does the dissolving is the solvent. The solvent is always present in the largest amount. That's important when we think about 2 gases mixed together like air. Air is oxygen, nitrogen, and some other gases mixed in. The way we know which one is a solvent is it's mostly nitrogen. Solutions are mixed evenly. They're often called heterogeneous. That's another name for a solution. A heterogeneous mixture was evenly mixed and it was the same all the way through. A solution can be a solid, like 2 metals melted together like an alloy. A liquid, or like air, gases mixed together. So 2 liquids could be like water and radiator fluid mixed together. That would be an example of 2 liquids. Okay, now the concepts here of things dissolving in each other are pretty simple, but what often confuses students is some of the vocabulary. So we need to kind of pay attention to some of the distinctions between the meanings of these different words. Solubility. The definition of solubility is the amount of a substance that can dissolve in a solvent, and it depends on 2 things: the nature of the substance and the temperature. So let me briefly explain. The nature of the substance. So let's say we're mixing something into water, and we're mixing either sugar or salt into water. So the nature of the substance, whether it's the sugar or the salt, depends on how much is going to dissolve. You can dissolve a lot more salt in water than you can sugar. So one of the things that the solubility, the amount of substance that a solvent can dissolve at a given temperature, is the nature of the substance. So in that example, whether it's salt or sugar. And then the temperature. Usually when we're dissolving solids into liquids, the higher the temperature of the solvent, the more that will dissolve. So for example, when water is cold, it won't dissolve that much sugar. But when you warm it up, you can dissolve a lot more sugar into water. So water has a higher solubility when it's warm than when it's cool. The solubilities of 2 substances can be compared by measuring. And we can measure the mass of the 2 substances. So the mass is the amount of grams of water that we put into the mass of salt that we put into a certain number of grams of salt that we put into a certain number of grams of water. We could do it by percent. We mixed 2 liters of this with 1 liter of that. Or we could do it by a percent. We could say it's a 15% solution, so it's 15% salt. Okay. Now, concentration. Okay. A concentration solution has a large amount of solute in the solvent, and a dilute solution has a small amount of solvent in it. So when we think about something concentrated, we usually think of this like being a strong solution, like lemonade has a strong taste. So if you're making powdered lemonade and the directions say to put 2 tablespoons of the powder in a glass and you put 4 in there, we would say it's concentrated, it's got a lot of flavor. If you're somebody who doesn't like it so lemony and the directions say put 2 tablespoons in there and you only put 1/2 of a tablespoon in there and you just don't use very much, we would say it's diluted. Another example that kids sometimes are familiar with is sometimes when you go to a restaurant, it's all you can, you get free refills. And sometimes the machine's not working correctly and it puts too much of the flavoring into the soda, and then it tastes really syrupy. That would be really concentrated with the flavoring that came from the soda company. On the other hand, sometimes it's not working, they run out, and then it's weak and it's diluted, and it barely tastes like Coke, and instead of it being a dark brown, it's a very light brown, and then we would say, well, it's really diluted because it's not mixing the flavoring into the drink very well. So we think of dilute solutions as being weak. And as we said, the concentration can be expressed by a percent by volume of the solute. So I put an example here. Diluted would be this light pink, and then we would say it was really concentrated when it was this really dark purple color here. So diluted to concentrated just sort of say like it goes from being really weak to being really strong. Now, where this kind of messes kids up sometimes is that sort of like that description, and it's almost like when you talk about colors, it's light blue to dark blue. That's like diluted to concentrated. But there's another point of solutions that's called saturation. A saturated solution is a solution that contains all the solute it can hold at a given temperature. So I want to come back to this picture for a second. This concentrated solution is not saturated yet. Okay? It looks like we could still put more of this coloring in and mix it, and more would dissolve. So a saturated solution is going to be concentrated, but it's also at that end point where we can't mix any more in. So it should kind of make sense. Like if we had water at room temperature, we started putting salt into it, and we stirred it and it dissolved, and then we put some more in and that dissolved, and some more and some more. Eventually, it would get to the point where when we put the salt in there, no matter how much we stirred it, it just wouldn't dissolve anymore. At that point, we would say the solution is saturated. It would also be concentrated at that point, but we would say when it was really salty even before that it was really concentrated salt water. So again, the concentrated and diluted are kind of like, if you want to make an analogy to colors, it's like light blue to dark blue, but it's not an exact point. Saturation is an exact point where that really concentrated solution gets full and it won't dissolve anymore. Now, the saturation point changes. It depends on the temperature. So I put in your notes, as the temperature of a liquid solvent increases, the amount of solute that can dissolve in it also increases. So if we had that salt water saturated at room temperature and we warmed it up, it would become unsaturated. Because at higher temperature, we could dissolve more salt into the water. Those saturation points are shown on a graph that's called a solubility curve. And there's a detailed graph on the next page that we're going to take a look at. And now that's a line graph that shows how much solute will dissolve at any given temperature. So remember, the amount that will dissolve changes, and it increases as the temperature increases. If we have not got to the point of saturation, the solution is said to be unsaturated. That means that we can still dissolve more in it. So on that last page where we looked at the light pink to the dark colored liquid, all of those were unsaturated, okay? You could add more to it, okay? So like we gotta be careful not to confuse saturated and unsaturated with diluted and concentrated. Diluted and concentrated are like kind of apply to all the unsaturated solutions. So, it's unsaturated when it's diluted, and then if it gets more and more concentrated, it's still unsaturated, and it gets more and more and more concentrated until it finally gets to the point where it's at the end and it is saturated and there's no more that can hold. So saturation is an exact point. And then there's a short video that I want you to take a look at on saturated and unsaturated solutions. This is a short clip on saturated and unsaturated solutions. So here at the beginning, he's putting the water in there and it's unsaturated. Now, it could be diluted or concentrated, we don't know, okay? I guess if it's just one scoop, we would say it's kind of diluted. As he adds more and more, it's going to become more and more concentrated, but it's still unsaturated because all the sugar dissolves. So now we add more sugar. And he's stirring and stirring and stirring, and it won't all dissolve. So now the solution is saturated because it won't all dissolve. It'd also be pretty concentrated as well. A supersaturated solution contains more solute than a saturated one at the same temperature. So remember, I said that solubility increases as temperature increases. So if we had that salt water and we warmed it up, let's say just before it was going to boil, and we dissolved all the salt that we could dissolve into the water at that high temperature so that it was saturated at 99 degrees, 1 degree before it was going to boil. And then we cooled it back down. When we cooled it back down to the lower temperature, more salt would be dissolved in the water from when it was a high temperature than should be able to be dissolved at the lower temperature. That extra salt that's dissolved in there is going to want to crystallize, okay, because we kind of tricked it by heating it up and getting it to dissolve at this high temperature, and then bringing it back down, we actually have more dissolved in the water than would have normally dissolved at room temperature. That's when we say the solution is supersaturated. So it says it contains more solute than a saturated one at the same temperature. And it's made so honey, syrup, rock candy are all made that way. Honey bees naturally do, and that's why if you leave it sit around, it begins to crystallize, because in the warmth of the hive, they've actually mixed more sugar into the water, into the solution, than should be there. It's made by increasing the temperature of a saturated one and adding more solute and getting it saturated at the higher temperature and then lowering the temperature back down without disturbing the solution. Okay? Because it's been tricked and it has this extra solute added to the solution, when we cool it down, it's unstable and it wants to crystallize. When it crystallizes, it gives off energy and produces heat. Now, there's a short video I want to show you on supersaturated solutions, and then we'll come back. Okay, this is a short video that I wanted to show you on supersaturated solutions.
Next experiment. This one is really cool. This is actually one of the first experiments I remember ever doing in 3rd grade, but we're gonna do it bigger. Here's another mystery liquid. I scratched off a bit of residue from when I made the liquid, and watch closely.
Now, she has a supersaturated solution there that she made earlier. And I put on the video, this is a supersaturated solution. Watch how it will crystallize when it's disturbed. And we said in the notes, when it crystallizes, that it releases energy when the temperature would increase.
A lot of people call this hot ice, and in fact it is pretty warm to the touch. We measured the temperature before and after it crystallized, and it rose nearly 30 degrees Fahrenheit. So what do you think this liquid is? What is it? Well, it's called sodium acetate, and you can actually make it with adult supervision by mixing a 1/4 cup of baking soda with 1 liter of vinegar, which we all know makes CO2 gas, which you can actually scoop out and pour out candles with. That's a bonus experiment. But the other stuff you make is sodium acetate. Then you boil that stuff for about an hour and then pour it into a jar, and you can just set that aside, cover it on the table, or refrigerate it until it's relatively cool to the touch. But sodium acetate freezes at 58 degrees Celsius. So what you did when you put it in the refrigerator and let it cool down is you actually super cooled it. You can super cool water below the point where it would solidify into ice. But the thing...
Okay, so if you noticed on the stove, she had the liquid and it was saturated. So she had made the sodium acetate and she had gotten the saturated solution on the stove when it was hot. And then, so it had all the dissolved stuff in it that it could at that really high temperature. And then she cooled it down in the refrigerator. When she cooled it down, everything that was dissolved stayed dissolved. But it was more than should be dissolved at the new temperature when she put it in the refrigerator and cooled it back down. So all that extra stuff, all the extra sodium acetate is dissolved, but it doesn't really want to be there. if we mixed it in at room temperature, it would settle to the bottom because it would not want to dissolve. That's why we call it supersaturated, because it's above where it should be. Well, everything that's above where it should be really wants to not be mixed in, and it wants to recrystallize. So watch what happens when she sticks her finger into the solution.
The thing is, it needs a nucleation site, a place for the ice crystals to start growing. So you can only do that with really pure water. But sodium acetate is really stable stuff, so you can supercool it easily, and then you need to put some crystals like the residue we used, or introduce your finger or shake it around or something like that in order to get it to start crystallizing. And that's hot ice.
I want you to answer these questions on your own, and then we'll come back and begin here. I hope you're having a great day, and we'll see you next time.